Hey, how's it going? Welcome back to the channel. Today we have a fun looking puzzle here. As you can see, there's a lot of arrows going on here, and that's really pretty much the only rule set. So it's another one of those that's minimalist in terms of the number of rules, but there's obviously a lot going on here. So let's take a look at what it is. So it's called, after I fix my frame actually, it's called The Underground Arrows by the Autistic Kantian. It's an interesting name. I don't know what a Kantian is. If anybody knows what that is, if it's a reference or something like that, let me know. Anyway, so we've got normal Sudoku rules apply. So every row, column, and 3x3 box will contain the digits 1 through 9 once each. Then we've got digits along an arrow must sum to the digit in that arrow's circle. So we have lots of arrows, as you can see. These two digits, whatever they are, will add up to this digit. And then we have the blue line goes from an arrow circle to the same arrow's tip, and so does the red line. Okay, so this is just differentiating between how these arrows work, because there's a little bit of overlap here. So this circle is connected with these two arrow because they're on the red line, and this circle is connected to these two arrows because it's on a blue line. So, okay, and that's it. So again, not a whole lot to say there. Let's just jump into this one, see if we can get it figured out, because it looks like it's going to be quite fun. So links in the description below. Let's get started. Now, the question, as always, is where the heck do we start? Well, okay, here's something I can see. And there's a little bit of a correlation, it seems, probably between these clues. So we have this set of 3 digits on an arrow. So they must be at least 1, 2, 3 as a bare minimum, which is 6. So this would be from 6, 7, 8, or 9, but this cannot be as high as a 9, because if it was, 9 plus what equals a single digit? Nothing. So this can't be 9. So this is either 6, 7, or 8, so there is a 1 on here. Now, the same isn't quite true here. Well, I guess there still is a correlation if you look at it from the other side. Again, this is a bare minimum of 6, 7, 8, 9. Now, this can't be 6 because it must have this digit plus something else to get to it. So therefore, we know that this is going to be this digit here is going to be higher than this one by whatever this is. And this whatever this is 1, 2, or 3. Now, we can't say the same thing about the ones over here. What else do we have? I was going to start thinking about what's going on with this middle region. Because we have 3 different arrows coming off of this. 2 of them are completely in the same region. The other one is half and half. Now, how do you make a digit that has to have 3 different ways of making it, is the question. So obviously this can't be 1, 2, 3, 4, or 5. Now it could actually be 6, because we can have a 4, 2, a 1, 5, and a 3, 3, because these are not in the same region. They're not in the same row or column. They do not have to have different digits. So this could be as high as, or high as 6, or high as 9, but no lower than 6. That's what I'm trying to get out. Then, what else can we say about that? Now, can we say anything about 7? Yeah, we can't. No, we can't. Sorry. We can't do the double digit to get to a 7, but we still have the 6, 1, 5, 2, or 4, 3 as options. Okay. So doesn't seem like there's a lot more we can do on this just yet. We could think about, though, the fact that there is a 1 on here. It starts to push up what this could be. Now, can we say the minimum here is a 2, 3? No, we cannot, because if we put a 2, 3 on here, what would we put on here? The next level would be 1, 4, 5, which is 10, which obviously does not work. So 2, 3 would not work here. So we can't, so we say this is at least higher than 5. So this is from 6, 7, 8, 9. Let's continue to think about those options. Now we almost have a quad here, but not quite. Maybe we can get something down here. Could this be a 2, 4, let's say? That would leave, no, that wouldn't work either, because we have 1, 2, and 4 all taken. The remainder here would be 3 and 5, which again is 8 plus 1, which is 9, but this cannot get up to 9. So this actually can't be 2, 4, which means this can't, well, does that mean that? No, it doesn't. It can't be 2, 4, it can't be 2, 3, it can't be 2, 4. It probably could be 2, 5, because we could put a 1, 3, 4 here. So this could get up to a 7. I think it still could get up to 6, though, because we could do a... No, we can't be 6, because the only ways to make 6 are 2, 4, and 1, 5. The 2, 4 doesn't work, but we can't go back to the 1, 5. So this is not 6 either. Okay. That wasn't wonderful, but it gave us a little bit, I guess, of added reduction. Now, let's maybe take a different tactic. Okay, where does a 9 go in this region? It has to go down here, because we can't put a 9 on an arrow. Is there anything similar? 9, okay, there we go. None of these can be 9, so there's a 9 here, which removes the 9 possibility from here. Now this is getting reduced. The 8, we can't quite rule out an 8 from all of these, because this could be... No, it can't be, actually. That's interesting, now that I look at it correctly. We can't put an 8 on here, because the highest this ever gets to is 8. We can't put an 8 on here, because this can only go up to 8. This actually can't be 8 either, because if it was, we need to put a 1 here to make a 9. We can't put a 1 here, we can only put a 2 as the lowest. So there's an 8 up here as well, which means this is 7. These are not 7 anymore. So there's something. Now, I don't know that we can say what the 7 is. We do know it. No, 7. Okay, we can make a determination about the 7. If we think about this region yet again, we can't put a 7 here by Sudoku. We can't put one here because we obviously can't put a 7 on its own line. We can't put a 7 on this guy because if it was a 7 plus a 1, we're already at 8 and we're broken. So this is 7. This therefore has to be 2 because it can't be 1, and this is a 9. There we go. That's a little something. Now we know one of these must be 7. Now we can't necessarily rule out... Well, I guess... Okay, let's think about that. If we know one of these lines has a 7 on it, that means we can only put a 1 or a 2 here. And I don't really like how this coloring is working for the overlap here, but I understand why this is a necessity to color them. But anywho, just because it's hard to see. But if this is a 7, this could be a 1 and an 8. If this is a 7, this would be a 2 with the 9. Now, we can't... can we? Yeah, because we can think about this 9, I guess. This is either a 7 or an 8. One of these is a 9 while I'm thinking about it. One of these is a 9 while I'm thinking about it. Now, this can't ever be up to an 8 because it would force this to be a 1, 9. So this has to be something less. It's either the 7 or something lower. Is there anything else we can rule out from these other digits that we already have? I don't know that there is. The 2 is interesting in a little bit. Let's continue with our 9s and see if there's anything else doing. Because there might be something. Let's just get rid of all this stuff and see if anything pokes its head up at us. These are not 9s. Doesn't really appear to be, does it? Okay, let's try to continue with what we've got. How are we going to go about that? Okay, this here. There we go. Because this is a 2 now, this can no longer be a 1, 2, 3, so this can't be a 6. This is 8. Therefore, this is 9. Therefore, this is 1. I'm going to see if that 1 is impacting anything, but it doesn't really look like it is, at least not yet. Now, if this is an 8, this can't be 1, 2, 5, so it must be 1, 3, 4. So we can put that in. This digit, bare minimum, can be a 5, because we can't do 1, 2, 3, or 4. So 5 or 6, because it can't be 7, 8, or 9. This can't be a 1, so it's either 2, 3, or 4. Let's just kind of get these options in here. This guy has to at least be 7, so it's 8 or 9, because it can't really be 7. Okay. This 7 we could probably figure out now, and that might hit this guy. Because we know it can't be 6, 1, it can't be 4, 3, so it must be a 2, 5 pair, which means this is not 2. We still don't quite know what this one can be yet, but maybe we'll get there. What are these guys? They are from 6, 8, and 9. Okay, now can we use this other information to help us figure out what's doing? Let's see. I don't think we can do too much more with this row. Excuse me. Well, I guess we can say this is from 5, 6, or 7. Because again, we can't ever go up to an 8 because it would break this. So this guy here must be from 6, 7, or 8. Again, this is a little bit hard to see because of that blue color, but it's not a big deal. This one, there's too many options, 5, 6, 7, 8, or 9, so I'm not going to go into that. These digits, or do we want to look down here maybe? Because this can't be 1, obviously. Can't be 2, can't be 3, can't be... Well, I guess it could actually be 4, which is interesting. It can't be 5, obviously. It could be 6 or 7. No, it can't be 7, sorry, there's a 7 looking at it. I guess it could be 8 or 9. Okay, not... Well, there has to be... Okay, there's a little bit more. There's a 6 in here somewhere because of the 6, 8, 9 looking into here. But it doesn't quite give us a ton here. Just try to think about where some of this other, like the 2 has to go up in here somewhere. I wonder if we need to get into some of these other guys now. To start parsing out what is what. Because we can start to say something like we got these 2 clues that we haven't even touched yet. We know this one is not 7, 8, or 9. Problem is it could be as low as a 3. So that's not huge, but we'll probably get something coming into this thing at some point where we can maybe start to batten it down a little bit. Are there minimums on some of these that we could look at? Don't necessarily see some. Seeing maybe if the 8 interacts. Okay, the 9s. We just had to go back to our 9s. We took a step away from them for a second. None of these can be 9s anymore, so this is 9. Therefore, this is not. And this isn't. So now we know what these are all adding to. I don't know that that necessarily tells us what these are, though. No, not necessarily. I was thinking about the combinations, because, you know, we could do 8, 1, 7, 2, and 5, or sorry, 6, 3, and 5, 4, and we can eliminate 1, 8 from both of these, but we can't eliminate it from this. I mean, we could say this isn't an 8, but this could be. I guess it puts an 8 down here, if that's really all that helpful, and puts an 8 over here. This can't be ruled out from an 8 because this could be a 1, 9 still. Okay. What else can we say about any of these things? 7, there's multiple places it could go. Again, do we want to try to figure out what the 9s are doing? But I don't think we can go any further still. So there's going to be some other line that we can look at here that's going to tell us what we need. Almost could rule out a 1 from over here, but not quite. Is there anything on those lines that are... Or is it going to be some kind of grouping of what these can all be? Because in terms of a value set, we know these are worth 9. So all of the remaining portions of this are going to have to add up to 36. But without knowing what these specifically are, we can't go too much further with that. So, I was going to say, thinking about how we thought about the 8s here, could also think about the 1s, but we can rule out 1s from all of those, but we can't rule it out from here. So we can't push it down here. That would be, well, I guess it wouldn't really do much if we could push it down here anyway, because we still have options up here, but still. All right. How are we going to determine? We got to think about some of these other lines. It's got to be the case. Keep wanting to go back to our 9s here. But I don't have much left there that's being removed from options. So, wish we could solve this guy. This is 5, 6, 8, or 9, which is pretty much garbage in terms of a marking set. What else is in this thing that I'm just not seeing how they're interacting with each other? Can't differentiate which one is the 7 yet, because this could still be a 7, 1, 8. Oh wait, no, that doesn't work, does it? Okay, maybe that's it. If this was a 7, this would have to be a 1, because we can't have a 7, 2 to equal 9. But if it is a 7, this becomes a 1, this becomes an 8, but we have a 9 with the 1, so these would both be 8s. This is not 7. Okay. This is 7, which means this is 2. This is no longer 6 or 7. It can't be 6 because we have a 2 here that goes with either a 5 or a 6. So this is 8. This is now an 8, 2 with the 6. We can put a 5 here. This is not 5 or 6. We get that 8, 9 pair. That's something. Good. Now this is resolved, so we don't have to worry about the visibility issues there. This can't be 8 or 6 anymore. So it's either 4 or 9. Now, sadly, it still could be the 4 because this could be a 1, 3 pair. There's nothing ruling it out. What about this 8 clue now that we have it? Does that tell us anything? Oh wait, well these can't be 8s. Let's just get rid of that first. We can't rule out... Oh, yeah, we can, because this is 6, 8, 9. None of these are 8s. So this is a 6, 8 pair, which means this is 9. Okay. Wait, that's not right. How did I put... Oh, I didn't remove my 6, or a marking for 6 for some reason, or something that I put in there. So we still can't put an 8 in any of these. So one of these is 8. Was there something else in this pairing here that I could work with? Doesn't look like it. Unless I can rule out the possibilities of 9. Because we can't do 8, 1, or 7, 2, or 6, 3, but we still have the possibility of 5, 4. So not quite yet. Okay. All right. So I don't know what that 6 marking came out of. It might have been a typo on my part. So let's go back to this 8 if we can. We know it's not 7, 1. It's either 6, 2, or 5, 3. This is not 2, so this is not 6. I don't know that. Yeah, we can't really seem to go any further with that one. Let's get rid of these 8s like we did previously. When I did the undo on this thing, that's what came out. Again, the 1 we can't quite rule out here. It would make more sense that it would go down here, but it's not necessarily the case. No, none of those are 8s. We know there's no 2s on these now. 8s. What's left over from here? We need a 1 somewhere, but it can go in any of those. The 3s and 4s can go anywhere. The 2 we already said is up here. The other thing that's left over is a 6. So one of these is 6. It's not great. What about you? You can't be 5 anymore. So we're starting to pare this down a little bit, but there's still way too much on it. Now, I guess we could look at these and see how it might affect this or how it might affect this. Because we can think about, if this is a 3, this is a 1, 2 pair. These would have to be from 3, 4, and 5, which clearly doesn't work. Can we do the same with the 4? This would be a 1, 3, so we'd have 2, 4, and 5. That doesn't work, because 4 and 5 by themselves are 9. So this is not 4, so this is 6. Therefore, this is 6. Get rid of that. And now let's think about what these could be. They're either 5, 1, or 2, 4. The 2, 4 is possible, because we could do 1, 3, 5 to get to 9. The 1, 5 is possible because we could do a 2, 3, 4. So what was the 3 was always in this, is that correct? Because if we did 2, 4, it'd be 1, 3, 5. If we do 1, 5, it's 2, 3, 4. There's always a 3 in here, which means this isn't 3 and this isn't 5. Small reductions, of course. Okay, is there anything further that we can sort out with this thing? It has a 3 on it, so it's either 2, 3, 4, or it was 1, 3, 5. I'm going to put all that in. 1, 2, 3, 4, 5. So we have a quintuple. There must be a 6 somewhere in here. It goes here. Therefore, this could be a 1 or a 3. It can't be a 2. So this is either 7 or 9. 1, 2, 3. No, we don't quite have a quintuple there. Now these are 7s, 8s, and 9s. We know this is not 9. So can we use that information? We get 7s, 8s, and 9s over here. Not too helpful. Sevens, 8s, and 9s is almost, we can almost put them into this region. If we could determine that was a 9, it would force these 3 to be 7s, 8s, and 9s. So we can make that work. There might be some negative constraint there that won't allow that to happen. We know this is a 9. Is there anything further with that? Or just look at the 6s. Why don't we do that? This is 6. One of these two is 6. What else did we find from this then? This is not 6. One of these two is 6. That gives us an X-wing. So none of these are 6. Okay, this has to be has to have a 6 on it. So therefore it has to be a 3-6. And this can't be 6. So it is 3 and 6. This can't be 6 anymore. So this is 6. This is working out. This can't, sorry, this is a 3. So these can't be. Get rid of that. Were we done with 6s? 1, 2, 3. No, we had the X-wing left over. That's right. Okay. Let's think about some of these other digits real quick. See if we can have anything obvious looking at us, or we need to go back into this 9 clue maybe. So what are our, oh, the 7 here means this can't be 7. We do get an 8-9 pair, but there's not quite enough there. Yeah, I don't think there is. Okay. I'm going to look at a couple of rows and columns real quick to see how it might affect our arrows. This guy could be 4, 5, or 7. Can't be 2, obviously, or the 1, 3, 6, 8, 9. So if that's a 4 or a 7, how does that work on this arrow? So this could be 3 or 5. Those are both still possible. If it's a 5, it can't be a 2 to make 7, but it could be a 4 to make 9. And if it's a 7, it has to just be it can't be a 7. Because if it's a 7, this has to be a 2 to make 9, and it can't. Okay. So we've got that reduced at least. Not entirely, but we can continue thinking about it. Is there anything now in this row that's even further? One of these two must be a 2. We can't say much about the 4s and 5s because there's multiple places they can go. I think same applies to the 7. We know either one of these two is a 7. We don't know which one exactly yet. Okay. All right. I think it might be time to go back into here and see if we can figure out anything that works to get to 9. Because we've already removed the 6-3 possibility. This one can't be an 8-1 or a 7-2, so this must be a 4-5 pair. There we go. Again, just making sure. 1, 2, 3, 4, 5. We do have a quintuple here, which means this is either 7, 8, or 9, and it can't be 9. So it's either 7 or 8. That's actually quite useful, because that forces this to either be a 1 or a 2. And one of these is a 2 by Sudoku. We haven't been able to rule out locations for the 1 just yet. What else? 5, 6, 7s, and 8s. Yeah, so we're kind of not quite through this guy. So I need to scan a little bit more. See if anything's jumping out. Maybe we just need to go back and look at our Sudoku. Remember, the 6s were still in the X-wing. One of these is a 2. One of those was a 2. Okay, I don't think we have much more low digits out here. What about these 7s, 8s, and 9s? Because we had gotten a couple of them. But it doesn't look like enough to really finalize anything. Oh wait, how about let's think about that 7, 8, 9 now that we've got some of this stuff in here. The 8 cannot go in any of these locations, so it must go here. The 9, well, it could still go in one of these. This, okay, so that's what this is. The 7 now is ruled out from all of these locations, so this is 7. And now we know this is 9. If this is a 7, this has to be a 4, 3. It's the only way it works. Therefore, this is 6. This has to be 2, and this should hopefully break this up a bit, because this now has to be a 1. This can't be 1 or 2. These have to add up to 8, so it must be the 3, 5, so it's not 4. Therefore, we know this is the 2, 4 pairing to get us to 6. And do we have anything looking at this? Okay, this 7 here, this is a 1. We have a 1 down here by Sudoku. What else do we have? We know what these are not 8 or 9, so that forces this to be an 8, 9 pair. Good. We know what this digit is. It's a 4 for the row. And we're probably getting pretty close to figuring out this column now. What are these 3 digits? Because it's going to tell us what this is. 3, 5, and 7. This can't be 5 or 7, so it just is 3. And that is going to tell us what this other one is. What is this? A 2, I believe. Yes, which is going to give us our 2 up here. And our 2 here. We finalizing our 2s? No, we have an X-wing left over here. Okay, but we're moving along pretty well. So what are these guys? Maybe there's something that it's going to correlate. And oh, actually, let's, like I was talking about before, let's go up to this column. You are a 1. You are either a 3 or a 4. 3, 4, 8, 9. So these are from 5, 6, and 7. This is not 6. Oh, wait, that 6 there was telling us that this is 6. So we can get rid of those markings. So we have our 5, 7, 8, 9, 3, 4, and the 1, 2, 6. All right, let's go back to rows then. We need a 5 and a 7. This can't be 7, so it's 5, 7, 5, 7, 5. This 8, 9 has to break at some point here. What are these 2 digits? 3 and 4, it looks like. Therefore, this is 4 and 3. Good. What are you 2? We need a 1 and a 7, so we can put the 1, 7. Good, that's going to tell us this is an 8. Actually, that 1 would have done it already too, but we got there in a different way. This is just a given 7, so these are a 2, 1 pair, and we have a 1, so 2, 1. That's got to get us something, right? Or this 8 will do something. 9 and 8. This is therefore 9. This is not. That 7 and 8 are looking down here, though, so they'll give us some work. And not 1. This one isn't 1. It's just a 4, which means this is 3 and 1. That 4 is going to give us our 5 and 4. That 3 is going to give us the 5 and the 3. The 4 gives us the 2 and the 4. That 2 is going to come back and give us the 5 and the 2. Almost there. Let's see. Well, let's go back here because that's where I was going to look previously. We need 3, 4, and 5. So 3 and 5 can't go here, so it's 4. These are not. This 9 actually gives us this 4 here, so that's going to tell us that this is a 1, 3 pair. Beautiful. This is actually just the 3 and 1 in this order because of these. Therefore, 4, 3. That's now going to tell us this is 8 and 9. And this should be pretty much everything we need to finish this off. This has been, we get the deet deet doot there. Okay. This is 5. This is 8. This is 9. There we go. It says it doesn't have a solution, but I'll pop it into the next one. There might be an updated one. I think I opened this a couple days ago. It's already 145 days in, so maybe it doesn't have a solution link, but I'll go through and make sure anyway. But anyway, fun puzzle. Really enjoyed that one. There was a couple of points where I got stuck trying to figure out how to get moving on some of these, but once it broke, it really ran quite well. So really enjoyed that puzzle. Hope to see more from this setter, like most of the setters, and hope you all enjoyed it. And then I'll see you in the next one. Thanks a lot.